3 tills, 3 machines, and one of the oldest problems in distributed systems. The things all of them have to agree on: the price list, the catalog, who counts as a member, which machine owns what. The textbook answer is to give all of those a category of their own, coordination state, and then give them a home of their own. That home is something you install, you operate, and you pay for alongside the application. It holds the shared values, and you write the code that keeps the two in step. A cache here, an invalidation rule there, and a job that reconciles them when they inevitably drift. But this case makes a completely different claim. It argues that this middle category simply doesn't need to exist.
We're looking at a design where the price list is just another character in the program, one who just happens to stand in more than one place. We'll explore the clerk and his journal, trace a price change step by step, see how replaying a past sale works, address the main objection around capturing, look at what's entirely absent from the system, and finally, define the strict boundary of this approach. So let's look at the clerk and his journal and what it means to treat the price list as a character. In this context, a puppet is just a character in a program. It's a named who, defined by his verbs, what he knows how to do, and his journal. And that journal is the diary of everything he's done, written out as sentences in order. That pair, the verbs and the journal, that is his identity, not the machine he happens to run on. Meet the clerk. He is an ordinary character, written like any other. But his journal is the price list. The prices aren't just data he was handed. They are the strict record of the price changes he performed. Now, that doesn't make him the system's single source of truth. The clerk is authoritative about what things cost now. What they cost on some particular day in the past is written somewhere else entirely, in the journal of whoever actually charged it. And that distinction is what this entire case turns on. His one real peculiarity is the word used to declare him. He's a stage V2 rather than a performance V2. That means he doesn't just live on one machine, he lives on all of them. On one machine, he's the director. The director is the only one that writes. On all the other machines, he's a cast, which is a replica that applies exactly what the director wrote. Let's trace how this handles a price change step by step. Let's say espresso goes from $2 to $2.50. Step 1. The request arrives at any machine. It genuinely doesn't matter which one, and nobody had to route it to a special machine. Step 2. If that request landed on a cast, the cast is never asked to write. It simply forwards it to the director. There's one single writer, so the change lands in one exact order, and there's nothing to reconcile. Step 3. The director writes it. The entry states that the clerk set the price of espresso to $2.50. Written out, it reads, clerk.setPrice, open parentheses, quote, espresso, unquote, comma, $2.50, close parentheses, semicolon. That is a sentence in his journal, not a row that someone updated. That record then replicates out to every replica. Step 4. On each machine, a local reaction fires, saying that the price changed. And that reaction never touches the network. There's no network hop, no timeout, no retry because the clerk was already there. Now, every cashier sells espresso at $2.50, reading the price straight from the memory of his own machine. Nobody wrote an invalidation rule, nobody enumerated which values to keep in sync. What traveled over the wire wasn't a value at all. It was the record of a price change. One thing this does not claim, and it's better said out loud rather than left to be assumed, is that it makes the copies instantaneous. A replica can be a moment behind the one that writes. That is a real property of this design, and it leads straight into the next question worth asking. What happens when replaying a past sale? This is where we see that the journal holds historical truth. When a cashier makes a sale, he doesn't store a reference to the price list. He captures the price directly into his own journal entry. That entry names 3 things: the item, espresso, the quantity, 2, and the price he actually charged, $2.50. Written out, it reads sell, open parentheses, quote, espresso, unquote, comma, 2, comma, price, colon, $2.50, close parentheses. That $2.50 is now a literal of his journal. It is frozen exactly the way a timestamp is frozen. So if you replay that sale 5 years from now, when espresso maybe costs $4, the replay doesn't ask the clerk anything. The journal already knows what it cost that day. Which gives us the sentence worth keeping. The clerk is a source of knowledge, not a source of historical truth. He tells you what things cost right now. What things cost back then isn't his to answer. That is already written in the journal of whoever made the sale. Naturally, this brings up an objection regarding handling the old price. You might look at this and say, hold on, if the price lives in a replica, and a replica can be a moment behind the director, then a counter could sell at the old price. Isn't that a bug you just designed in? Well, it's a real property, and it's worth being precise about rather than waving it away. Two machines can capture different prices for what looks like the same logical moment. But notice what does not break here. Each journal stays honest. Every sale records exactly the price it used, and every replay reproduces exactly that sale. Nothing becomes unexplainable later on.
And for cases where that is genuinely unacceptable, there's a knob. A decision requiring a linearized read simply pays the trip to the director and reads it there, giving up the free local read. Most catalog-shaped things tolerate the local replica just fine. The ones that don't, pay.
It's crucial to understand that capturing is not caching. A cache is asked again, and it can answer differently the second time, which is exactly what makes a replay drift. A captured value was asked once and then became part of the sentence that was written down. It cannot answer differently later because it is no longer answering, it's recorded. And remember, the director writes, a cast applies. A cast doesn't compute its own version of the price list. It applies the exact same record in the exact same order. So, what is absent here? We've successfully removed that entire middle category. There is nothing extra to install and operate alongside the application to hold the shared values. There is no cache, and therefore no invalidation rule to get wrong. There is no reconciliation job for when the two copies drift, and there is no synchronization code written by anybody. Coordination was not added to the model. It emerged from it, using the same journal, the same replay, and the same replication that were already there for ordinary business characters. Finally, let's look at the boundary and the cost. A claim without a boundary isn't worth much. So here are two things this definitively does not do. First, it doesn't make the cost of agreement disappear. Somebody still has to decide the order in which changes are recorded, and that somebody is the director. What changed is simply where that cost lives. It lives inside the program, visible and replayable, instead of in a separate system you have to operate. Second, this dissolves the catalog shape of coordination, things like configuration, membership, and price lists, the things that are read constantly and written rarely. It does not dissolve coordination tied to liveness, things like ephemeral locks, leases that must expire when a session dies, or ownership that depends on a heartbeat. That is a genuinely different regime, not a symptom, and pretending otherwise would be overclaiming. For decades, the things a system must agree on were treated as a different kind of state, deserving a different kind of home. Look at what happened when they were treated as an ordinary character instead. The price list got a name, a journal, and a history you can read, and the extra machinery it used to require simply had nothing left to do.